हेलो फ्रेंड्स, वेलकम टू माय यूट्यूब चैनल। इस वीडियो में हम सॉल्व करेंगे प्रॉब्लम ऑफ रेटिंग 800 टू 1600। टोटल इस कॉन्टेस्ट इस जिम में टोटल 6 प्रॉब्लम्स हैं ऑफ वेरियस रेंजेस फ्रॉम 800 टू 1600। सो लेट्स सी हाउ इट गोस। अगर ये आपको भी प्रैक्टिस करना हो तो मैंने इसका लिंक डिस्क्रिप्शन में दिया हुआ है, आप वहां से प्रैक्टिस कर सकते हैं। इस जिम में टोटल 6 प्रॉब्लम्स हैं of various ranges from 800 to 1600. So let's see how. हमारा ये कॉन्टेस्ट स्टार्ट होने वाला है अराउंड 1 मिनट में। यार आप बाद में भी प्रैक्टिस करना चाहो, मतलब जब लाइव खत्म हो जाए तो भी आप डिस्क्रिप्शन में लिंक दिया हुआ है, वहां से जाके प्रैक्टिस कर सकते हैं। हमारा जिम स्टार्ट हो गया है, सो लेट्स गेट स्टार्टेड। हमारा फर्स्ट प्रॉब्लम है लॉन मोवर। The exit from the summer cottage is fenced with a fence consisting of N boards, each 1 meter wide. To the left and right of the exit, the fences of other plots. Some of the boards of the fence want to be removed for the construction of a bathhouse, possibly all or none. While there is an automatic lawn mower on the plot that is W meter wide and must not leave the plot through a hole in the fence, the lawn mower will be able to exit the plot if there is at least W consecutive removed boards among the number of removed boards. Determine the maximum number of boards that can be removed from the fences. Each test case contains a T and number of boards and the width of the lawn mower in meters. Find out the single number maximum number of boards that can be removed from the fences. Okay. There are n boards with 1 meter wide. Example देखें तो there are 9 boards. And the width is okay. The summer portal is fenced with a fence consisting of n boards, each 1 meter wide. To the left and right of the exit are the fences of other floors. Some of the board of the fence wants to be removed for the construction of a bathhouse, while there is an automatic lawn mower on the planet that is W meter wide and must not leave the floor through a hole in the fence. Okay. The lawn mower will be able to exit, but if there is at least W consecutive remove boards among the number of the boards can be removed from the fence. So basically, we are given n boards and which are of 1 meter wide. So let's say for example one, if we consider, there are 9 boards. Each and the width is one, two, three, four. Now lawn mower can pass through it if there if its width is W, let's say. So we have to make sure that at any moment we don't have W consecutive empty ones. So to solve this, what we can do is, let's say from starting, remove W minus 1, keep 1, then again remove W minus 1 and keep 1. In this way, we will be able to handle this case. So in short, if we see that if our width is W, then we are keeping 1. So total that we will be keeping it, if there is, let's say, something n number value minus 3, we don't have to keep. The total that we are keeping is n by W. So we are removing total is n upon n minus W. So this should be the our answer for this problem. Let's try to code this one. Put N as input and W as input. Our input is this is 6, 10, 14, 0, 9, 77. Okay, if we submit this code, our code is running on like given test cases. Let's check on remaining test cases. Yeah, we are submitting this code. In the meantime, we can open our second problem that is removal gain. It is still running. Oh, yeah, our code got accepted. So it was a quite a simple problem in which we just have to make sure that we don't leave W consecutive, otherwise it will pass through it. And that's all was the logic for this one. Let's move on to our second problem for the day, that is removal gains. Alice got a permutation E1 to En of 1 to n, and Bob got another permutation B1 to Bn of 1 to n. They are going to play a game with these arrays. Both Alice and Bob have permutation of 1 to n. In each turn, the following thing happens in this order. Alice chooses either the first or the last element of her array and remove it from the array. Bob either chooses the first or last element in each array and remove it from the array. The game continues for n minus 1 turn, after which both the arrays will have exactly one remaining element, x in the A and y in the B. If x equals to y, Bob wins, otherwise Alice wins. So both the players will like so both there is an array. Let's say for Alice it is array A, and let's say for Bob it is an array B. Now what happens is they will remove uh, either first or last element. Now at the end we will be left with one element in A and one element in B. If let's say that is X and that is Y. So if somehow X equals to Y, then Bob wins, else Alice wins. Let's see how we can handle these test cases. First, Alice is making the move. It is always in the best interest of Bob that it should remove the elements which Alice has removed. If this does not happen, then Alice will keep removing other elements. As an example, if Alice has removed 2 and Bob somehow is not able to remove 2, it has removed 1, then Alice will never remove 1 from her array because if because in this case one can always remain and Bob will not able to keep the one because he has already removed. So at any moment, if Bob is not able to remove the element which Alice has removed, then Alice will be able to win it, else Bob will be the winner. Now we have to check like it is possible like how so if we for each number we will just see what is the minimum number of moves required for both of them. Let's say for an example, if we see for example it is 1, 2, 3, 1, 2, 3. This is for Alice and for Bob it is 2, 3, 1. This is for Alice and this is for Bob 2, 3, 1. Now if you see Alice can remove one in minimum move will be like 1. She can remove directly. For 2 at least uh, 2 moves will be needed. First she has to remove like one of the first or last and then it will take 2 moves. And for third, 1 move. Similarly, 1, 2, and 1. Now, if at any moment, like if at any moment in Alice there is a number, let's say whatever number it is, whose minimum move is less than what it is there in the above, then Alice can always remove that element and always win. If that is not the condition, then like Bob will win it. So if for any I, um, result at I, let's say this is a result one array and this is a result two array. So, second. So result one at I becomes less than result two at I, then Alice wins. Else, else you can have like Bob will be the winner. So this will be our approach for solving this problem. Let's try to code this one. We can create both two results. Okay, this is interesting. Here I will be max or min of I plus 1 and minus I. Similarly, uh, you can do for above. Now, if at any moment, let's say, just the result is, if at any moment result of I becomes less than this result to a dice, we can always take it from here. If result is true, then we know Bob wins, else Alice will be the winner. I think this is the what this approach is. Now let's try to run on the given test case and see if it's working. Answer is Bob and Alice, which is correct. Now let's run on all the hidden test cases. See if we are able to if the code is running correctly or not. So this is the let's commit it. In the meantime, we can open our third problem that is first or second. No, we are getting a wrong answer on test case 2. Okay, let's try to understand what's the wrong here. Results from the ARI is system mass dot minimum of I plus 1 comma n minus I. Okay, this is the minimum taken and if at any moment result 1 comma at I which is minimum move taken to remove I from uh, by Alice is less than what it is taken by Bob, then results can be false. Because in that case, Bob have to remove some other element, and then Alice will keep that element and keep removing other elements. So this is the basic idea for this approach. But let's see where it is scaling it out. I think the approach might fail in, let's say, condition where 1, 2, 3, 4. Here it is 1, here 2, 1 and 4, 2 and 3. Now, first thing is like Alice is removing 1, so Bob has to remove 1. So, Bob, now if you see, we are left with 4, 3, but here it is 4, 2. Alice can always remove 2, and now Bob will have to remove something else. And in this way, we get a disparity. So how to handle this thing? Suppose if it was 1 here only, 1, 2, 3, 4, 5, and 5 and 1. Now no matter what you remove, it has to be 4 in this case to handle such condition. And you remove this 1 somehow, 1, 1 is removed, not 2, 5. So this has to be 2. Can this be like 5, 2, 2, 5? No. Okay, let's check for some other also. 1, 2, 3, 4, 5, 6, 7, 8. Now we can always swap 8 and 1. But if you remove 1, then it becomes 2 here. And similarly, if you remove 8, it is 1, 7. Okay. Now let's say remove 1, 2. It has to be 3. In a way, BRSI should either be a copy of this or reverse of this. Copy or reverse. If these two conditions are true, I think then this should be working out, else you might get a wrong answer. Yeah. So let's take it in this way. I think this should work out. The Boolean result is equal to false. If the result one is true, our result is true, then that is Bob will win it, else Alice will be the winner. But you have to take input also, you must take a then take. Let's first submitting this code and yeah, as you can see that yeah, this code got accepted. So basically we just only put there are two conditions. Suppose if here at I is just a copy of this or if it is a reverse of this. If any of these two conditions is true, then Bob will be able to win it, else Alice will find a way to win it. So this is the like core logic for this problem. Let's move on to our next problem for today. That is first or second. There are n children standing in a line where the niceness of the ith child is AI. Santa is deciding which children belong to the nice list and where and which belong to the naughty list. So we are given n children and their niceness are given with the number A1, A2, A3 till AN. An integer x is initially set to 0. Santa will perform the following operation exactly n minus times. Okay. Initially, we have a variable x which is 0 and total n minus 1 operations will be there. Okay. In each operation, you have to choose the first or second child in the line and remove them from the line. Let W be the niceness of the chosen child. If the first child was chosen and then add them to the nice list and add W to X. If the second child was chosen, add them to the naughty list and subtract W from X. Note that after all operations, exactly one child remains unassigned to a list. So we have to find maximum X. So if the first child was chosen, okay, and let's say in this example, we can choose a child 2, 3, 4, it will be 4 plus 3 plus 4, and there's no. We have to choose the first child. Yeah. So 1, 4, 3. Okay. If we are choosing the first child, then we can directly add that to our result. And if we are choosing the second child, we have to subtract that number. So that let's see what can be done for this one. Let's say our x is initially 0 and there are two conditions. X is this is given as a first child or a second child. But we have to ignore one child also. So what is the value of n here? So actually what is happening? If we are ignoring, let's say, ith child, if we are ignoring the ith child, then all the child after this one are basically a second child only. And all these ones can be either like first child or second child, depending on. Okay, either first or second. But at the end, there will be one child which will be second to this. So that's fine. So how to handle this list? Let's say we are given four childs over here. One thing you can think of is, let's say our first child, the first child, and whatever it is, if second childs are positive, this is positive, then we can simply add this value. If they are negative, then we can keep this and subtract this value. In this way, if it is negative, then we will keep subtracting, subtracting. If positive comes, then we can add this thing. So overall, our answer will be, let's say for this one, 2 plus 3, 5, 11. The reason is out of minus 4 comma 2, you are doing minus 4, then, but yeah, we will be left with one child also. That is also true. But we have to we have to do this. So minus 4, let's say for this thing. First we do minus 4, then plus 2, minus 2, and plus 6. So yeah, this should be our approach. Uh, In first, like we will create a one array AR1 in which we will keep storing like what is the unsettled I if we are taking it. And unsettled I is basically if I is 1, then we can simply take this element. Else, if it is positive, then we can simply add this to our answer. If it's negative, then we can subtract that. In this way, we can find answer till I. If all these elements are second elements here, in this case, we directly have to take it. Uh, like we have to subtract those elements. And finally, answer will be like, let's say this is a array 2. Uh, Answer is like simply sum of these two elements. And we have to just maximize it. Let's try to code it and then maybe we'll get it slightly more. First, we are given an integer n and array. So this is our input. Then we have an left array. Then we have an right array. For left array, if I equals to 0, then simply left at I equals to a at I. Else, what we have to do is, if a at I is less than 0, we can take this as long because it will exceed our integer range. So let's take this as long. If a I is less than 0, then left I is just to left I, left I is just to this thing. Now let's solve for right, which is simply this thing. Right at I, Now finally, like we have to print our answers. So let's our answer as now as in every case one element will be left out. So let's handle this case. If I equals to 0, so as answer equals to left dimension plus that is I plus 1. So it should be next by this. Let's run our case and see. We're getting 12, 11, 1, 15, 2, 11. Okay. I think this is fine. At 3, 8, 4, 15, 8, 15, minus 1, 29. I think this is running on our given test cases. And let's try to submit it and see on the remaining test case. In the meantime, we can open our first problem that is incremental path. As you can see that yes, this code got accepted. So I will explain logic for this one. So as you know that we have to perform total of n minus 1 operation. So whatever we have to do, we will be left with one element. Let's say that element is I. Now we are, if you see for I, there are two parts of this. One is left part of I and one is right part of I. Left part and right part. Now if you see the right part, since I is already left, so for all the elements of the right part, I will be the first element and these will be the second element. So this is how we can handle the case for right element. And for right element, we just have to do is subtract here at I. So as you can see in the code, we have created our right array, which is basically to handle the right side of it. Now consider the left side of this array. For the left side, there are we can handle it any way. Now suppose this is our first element. This will always be a first element no matter what. Now a other element comes in, which is a positive. Now, if other element is positive, then you can take this element because other element is positive. So this will add positive answer to our result. Now suppose this is the first element again and the second element is negative. Then don't pick first element, pick second element because if element is negative and you are subtracting this, so it will become positive. Like so in this case we will do positive thing. So similarly we will create a left array which you can see here. If I is 0 then simply left is here at I and else if number is negative then we are subtracting it else we are adding it. Now as we have created both the left and right subarray, now just we have to for each I we have to calculate what is the result. For each I we have a left array, right array. So answer is like left of I minus 1 plus right of I plus 1. We just have to maximize this value for all I, and that will be our final answer, which is what we have done here. And just we have to print this answer. So this was all about our third problem. Now let's move on to our next problem, that is incremental path. Hats are disabled in this problem. There is a strip containing 10 to the power 9 cells numbered 1 to 10 to the power 9. Each cell is either black or white. Initially, M distinct cells are black and others are white. So we are given a strip of length 10 to the power 9. Let's say this is our strip from 1 till 10 to the power 9. Out of which there are M distinct cells which are colored black. So there are M cells, let's say A1, A2, AN, which are black and remaining are white. A person is on some cell X. He might be given two types of commands. Jump to the next cell X plus 1 or jump to the next white cell I with a minimum Y which is greater than X. So that cell Y is white. Okay, so if a person is on a cell X, he can jump to either X plus 1 or next Y. There is a string S of length n consisting of n commands for each I 1 to n in order. A person starts from cell I, execute the first I command in the string, colors the last which cell as black. If it was already black, it remains black. You wonder which cells are black at the end of the process. Print them in increasing order. Okay? So we are given these m cells. Initially, person is on cell 1. Now he has to follow some commands. Let's say whatever it is, BAB. A means jump to the next cell. This is a command name for this is A and command name for this is B. Mm, Now we have to just print like what are the cells that will be black at the end. So let's take a second example for doing this. Our our string is A B A. Our string is A B A, and our black cells are 1, 4, 9, 10. Our black cells are 1, 4, 9, 10. So out of all these cells, we 10 to the power 9. Our first cell is black, and second, third, fourth cell is black, fifth, sixth, seventh, eighth, ninth is black, tenth is black, and rest all are white. Now we have to follow this code. Currently, we are sitting on cell 1. Now, what is our command A? As you see, our command A means move to the next cell. That is, we will move to second cell. Now, our command is move to the next white cell. And we have to color the cell we have come from with black. It was already black, so there is not a problem. Move to the next white cell. That is uh, this thing. Third cell. We have to color this with black. Now we have to follow A, so which is move to the next cell 4 and color this with black. So we have like 6 cells which are colored with black. One, 2, 3, 4, 6, 9, 10. 1, 2, 3, 4, 6, 9, 10. Okay, okay, sorry. For this problem actually, we have I person will execute first I commands, then second person will execute next I command. So this is the order we have to follow. So let's say the first person follows a command. So in this, what will happen is our what this mm, will get colored. So this 1, 2, 3, 1, 2, 3, 4. Now, when we follow the first command, this will get colored with black. If we follow A, B, so first, second, these two will get colored this. If it has to execute first I command. So after first I command, it will reach here. Now again it has to execute A and B. So after it will reach here, after B it will reach 4. So this will get colored. A third person will execute A, B, A. So in this case, first it will execute, it will reach here, then it will reach here, then it will reach here. Okay. So what is happening is, suppose a string is given, this one. A first person will execute like till here, then other will execute this command, and third will execute this command. Now, wherever you reach at the end of this list, means after executing these commands, uh, you will be basically you will like color. Basically, you will color that thing, color that box, and now you have colored that box with a black color, and you have to just print what all black colors are printed at the end. So this is what we have to do. This can easily be solved in M square, but we have to implement in log n or something like that. Should be just true. If we are following simple operation which is A, then we are just moving to the next cell. So our bigger jumps comes from B only because it takes us to the next white cell. So in a way, let's say for first operation, we have to do like we have to move to the third white, third remaining white, and after that, let's say simple P operation. Similarly, maybe like for next rotation, we might have to move to some number of whites, like X white, and then move simple operation. But using simple operation also we can move to white, so that will not work out. Let's think of something else. If you see general correct of thing is like let's say we will perform some number of A, jump to next white, then simple increment, then jump, then simple increment, jump like this. And wherever we will reach last, that is our last cell and we will color that thing with black. What is it this one? How we will like implement this thing? That will be our thing. Hmm. I'm trying to think through like what can be done in this one. A brute force approach can be like just run through it and then find it out. But our brute force will not work here because that will be an straight solution. Simple approach is whenever you are given x consecutive age, you just directly reach till that point. Then trying to find next y, it's again white, then again white, and then if it is like reoperation, then find next empty shell, and in the end, you reach a point. Interesting. What is the issue with this approach? Let's see how brute force will
come up and then we will try to optimize as well. And so let's take a third example, A, B, A, B, A, B, A, B, B. And the cells that are initially black are 1 and 7. 1 and 7. Okay, if we create this one, first is black, second, third, fourth, fifth, sixth, and seventh is black. Now, a first person will execute command A. After executing command A, we just notice cycles. So this will be also just converted to black. And we can play with black only. A second command is AB. The first is using A, it will reach here. Using B, it will reach here. So this will also get black. Next, third is AB is using first, using second, and then this. Using first, using second, using third. Where is here? Sorry, I'm not this one. This one. Fourth is A, B, A, C. Using first, using second, using third, using fourth. We are basically reaching at this point. And finally, A, B, A, B, D. So, using first, we will be share second, third, fourth, fifth. So, we will be finally switching here. So, our answer will be 1, 2, 3, and we'll leave 4, 5, 6, 7, and 9. This will be our answer for this problem. 1, 2, 3, 5, 6, 7, 9. 1, 2, 3, 5, 6, 7, 9. So that is 3. Now you have to see like how to approach this one. Let's say we have done an equation till A, B, A, A, B, A, B. Let's say this is like finding the second y. If we look at closely, this is initially your 1. After performing this, it will become 3. Then a white after 2. is the number, then you see z, z plus 1, right after z plus 1. This is what it is currently doing there. But how to write the process? We will be get back to this problem later. But currently, no idea is coming. We'll see this problem for now and then if this is our largest subsequence. Given a string S of length n, in one operation you can select lexicographically largest subsequence of string S and the cyclic shift to the right. Your task is to calculate a minimum number of operations it would take for S to become sorted. A report that it never reaches a sorted state. String A is lexicographically smaller than string B if and only if one of the following holds. A is a prefix of B, and in the first position where A and B differ, the string A has a letter that appears earlier in the alphabet that corresponding to letter B. Given string of length n, you can select lexicographically largest subsequence of string S and a cyclic shift to the right. Your task is to calculate the minimum number of operations it would take for S to become sorted. What is required to make has sorted or -1 if it is impossible. Okay, we have to make this string sorted. If you see first one is already sorted. Uh, Second one is not sorted. Let's say if a subsequence is given, and let's take an example. So you can take this ZBCA, ZBCA. Now we have to make it as sorted away. So our final answer will be A, B, C, Z. If we these two are already in the line, so we just have to move their position. That should work out. Where is the answer for -1? Not third one. It is ACB. Yes, this is why answer is not sorry, BSC. So BSC we are getting -1. So B is C. You can't solve this thing. You have to select the lexicographically largest subsequence. Okay. So in this range, if this plus let's say ZC, we can just see Z, we can get C Z. How we will start it actually? ZC as you take it, it will become A B C Z. Okay. Instead this here to take this sequence ZCA, then becomes AZC. Now our subsequence is AZZC. As we take this ZC, it will become CZ. So ABCZ. Okay, fine. So logically, our largest character should always be included, else we will not be able to sort it. This is, I think, what your largest character Z. Then with which we are starting with. After that, second largest is E. And Z M Z M. M is Just taking all this you can see. Red M I G E C. Z will come here. Z and M I G E C. Okay, let's just have one, two, six situations. This will become something like P, P, D, I, N, N, K. This will become distant, and then what we can bring that answer. What if we have like string character? Basically, what we have to do is uh, find the largest character, the starting index, then from here again find the largest character again and again, and reverse this. If a final array is sorted, then you can say, yeah, we are able to sort it, and number of question is like length minus one. Else we can say that we are not able to solve this one. So let's move on to the coding part of this one. We are given on some. Step 2, extract the largest number. Now we have to replace that number in this. You can teach a starting ID. We can replace that number and we just have to do a system. So we can equal to 0 and do the can make it refill the way. Now that will be your fun array. Now this array should be sorted. So if it is sort, if it's not sorted, so we have that ID and answer is false. Then we can just print it. Answer is true. Ignition. Helium master can be let's run on the given test cases. See if it is working. We are getting around 59 we are at a segment here. Fuel statement 47. This will extend getting 60. In null contract 30 is line. So this is the line we are getting null contract section. Let's see what is the reason. Let that replace the order schedule. Yes, sorry, not should not. Again. For the last test cases, we are getting a wrong answer because ZZ means tension only. So how to handle this? The reason we did it was, let's say if we somehow fall like this. Logically, it should become something like this. Maybe let's take another example. So Z, Q, Q, P, P, and A. So it should be something like this. But let's say if number supplement is one only, then in that case, uh, we should answer should be zero only. Or even if it was, let's say like this. Then in one stepping only we are able to get it done. So we have to see like how we can minimize it because logically we are using four operation here, which we should not be using. Even for this case, if after moving all this into the front, we don't have to swap the last two elements. So yeah, we have to exclude this part. So we have to see what is the count of the largest number here, and then we can exclude the that convention. Is result is list of size and the largest ID and largest ID is minus one. It's in the top that will be better. And if largest ID largest ID is the max of all, and we have to just remove its count. Okay, if this POI is equals to largest ID, then final result is simply minus one. We just have to print the final result at the end. Now if we run on this test cases, we are getting 0, 1, minus 1, 2, 6, 0, 0, 1, minus 1, 2, 6, 0. So it is running on the given test cases. Now we have to check for all the hidden test cases it is running properly. So let's submit our code. And this is currently out in the key. Let's refresh it anytime. It's still in the queue. Do you have any contest run? Yeah. We have a contest running. I think that is the reason our problem is in queue. Okay, we will like see if later if it is getting accepted. In the meantime, we can try a different problem, which is a binary string copy.
You are given a string S consisting of n characters, which are 0 and or 1. You make m copies of the string. Let ith copy be the string Ti. You then perform exactly one operation on each of the copies. For the ith copy, you sort its substring between Li and Ri. Note that each operation affects one copy and each copy is affected by only one operation. The task is to calculate a number of different strings among T1 to Tn. Note that the initial string S should be counted only if at least one of the copies stays the same after the operation. So we have to make m copies of the string, let ith copy the string Ti. Then you have to perform one operation on each of these copies. For the ith copy, you sort like Li between Ri. Your task is to calculate number of strings among these different strings. Okay. So for the ith string, you are basically sorting between Li and Ri. Now we just have to print like what, how many different strings we are able to make it. Like an example, if you take 101100, 101100, and what are the, okay, I think, yeah, our text problem got accepted. So yeah, mm, that was the correct logic for this one. Like we just have to find that substring and then just reverse it. That was all we have to do it. So, yeah, we were solving the sixth problem. So suppose this is our this is our string, and then we have to, let's say, sort between this. Like suppose if you're sorting between one and two, first one is you're sorting between one and two. Now if after sorting your string will become something like 0 1 1 1 0 0. Second, you are sorting between 1 3, then 2 4. Okay. Let's just write it down everything. 1 3, 2 4 5 5, 2 4 5 5, and then finally 1 6. 1 6. Now, if you sort between 1 and 3, again, if you sort this, it will become something like 0 1 1 1 0 0. If we sort like 2 to 4 part, like this part, your substring will remain same because it is already sorted. So 1 0 1 1 0 0. If we sort 5 to 5, then again it will remain same. And if we sort 1 to 6, it will become something like this. So if you see, these two are same only. These two are same, and this is different. So overall, like we get a total three different strings. So this is what we have to basically print it out. So how many strings that we can, what, how many unique strings that we can get? Okay, so what can be the approach for this problem?
If you go by brute force approach, then it will work in open square. Like for each L and R, you just sort it and then store in somewhere and store in somewhere, let's say set, and then count the size of set. But we have to somehow solve this problem in maybe n log n at max. The only advantage we have is the characters are either 0 or 1. So we somehow have to use that thing. The reason being is suppose between L and R, you can always count how many zeros and ones are present. Then, and sorting is like obviously all the zeros will come first and then all the ones will come. Now, how to use that in our problem? Let- These courses are accepted by only one of the classes supervisors and thus the initial students should be counted only if at least one of the copy stays came after the operation. Extension only. Let's say we try to make something like this. Suppose we are given something 1 0 1 0 1 0 1 0 1 0 1. And this can make us something like 1 1 1 0 then 1 1 then 1 0. Like this we will store it. And whenever we are reversing something, we will just like change that part. But even storing a string takes actually uh, of n. So if we are storing it for n times, will be on the square. And let's look for other approach. What can be done different? Let's say when we changing between cells, or we can find out what are the index that got affected. Let's say if in the starting it was already 0 and then it was already 1, then they won't be affected. But if it is something like this, they can be get affected. If we can find what are the index that got affected, let's say L dash and R dash, for each one of them, base, And then just we have to take the count of this. Let's say, I mean, what is the maximum number of index that is getting affected in a way? Like, suppose in the first it's let's say one, two, three got affected. In the second, let's say two to four got affected. In the third, let's say three to four, maybe four to five. So if you see like this three comma four, right, this three comma four, this is like same here, like it comes inside this only. So what we will do is like if we find out all this index, then we can basically sort by L and then R. So maybe let's say, and yeah, we can sort by let's say L comma R. Now if this 7, if the end of this is less than 7, then yeah, this will not be counted. This way we should be able to solve it. Let's see page at correct. So let's try this approach on our given test case and see if it is working or not. So we were discussing about this one, and if you look at it in the first case, what are the index that is getting affected? Like 1, 2. Between 1 and 3, it will become, let's say, again 1, 2. Between 2 to 4, 1, 2, 3, 4, nothing is affected. So here we can give it, let's say, -1, -1. In the fourth, again, nothing is affected, so -1, -1. And in the fifth is 1 to 6. That is affected, last 0 and 1, or everything is affected, 1 to 6. So yeah, we can see there is three unique things. 1 to 2, -1 to 1, and 1 to 6. So I think that this approach will work out. We just have to for each L comma R we have to find what is the first and last index that is getting affected. Now we have to look at into it how we will find for each L and R. Now suppose best approach should be if we are given an L and R, let's say something 1011 something, some number is there. Now for any L comma R, we have to find first one and last zero. Let's say this index is ID1, this index is ID2. So obviously, index that is affected are ID1 to ID2. But this will be only true if ID1 is less than ID2. So because if it is already sorted, then nothing will get affected. Else we will just add -1 comma -1 to our answer. Because as an example, for 101, only these two are getting affected because to sort it, we just have to like, do this thing. But if it was something like, let's say, 011, then we don't have to do anything because it is already sorted. So we will follow this approach only. Let's try to code it out. We are given an and let's see the current code. We are given n and m and a string s. Then for n line, we are given L and R. Now, what we have to do is we have to store all the zeros and ones. So let's say zeros we can store here, and in ones we can store in ones. Now we have to iterate through all the elements of the string S. That can be like this. ID is 0, then we will add in the zeros. Since indexing is from 1 to n, so we will add I plus 1. And similarly for 1. Now we have to look for, we have to find L dash comma R dash for find L dash R dash for L comma R. Now what we can do for finding is, like as we were discussing here, we have to find first one. So say ID 1 is minus 1. This is basically first one, and this is last zero. So to find the first one, we have to look for one. Because the feeling of L is not null, and then in that case, simply this will be the one. But we have to make sure that this should not be greater than R because then it will like it will not win the limit. So that we have to make sure. Again for zeros, we have to find the last zero. So if floor of R is not null, then we can simply update it zeros dot floor of R. And again, we have to make sure that this should not be less than L. If it is less than L, then we can simply update it to minus 1. And if either of them is minus 1, then we have to again update it to minus 1 both of them. And if again one more condition that is different. If ID1 if ID1 somehow is greater than ID6, greater than when equal to, they will not be equal, but still, then again we have to add this minus 1. So yeah, this should be our all the ID1s, and we just have to find unique ones. So let's say our primary string is this, 5 plus equal to integer dot string ID1 star, and then finally ID2. We can add this in the step and like find the size of the cells actually. So that thing, and we can just print the size of the. Let's run our given test case and see if this is working or not. Outcome says 331. We are getting 331 only. So let's submit it and check on the remaining hidden test cases, like if it is running or not. And because contest is running, so it might take a little while to run it. But in the meantime, we can see our problem 4, which we were not able to solve in the starting. So this is the one. It is still in queue. Okay, we will see the problem is for a while. What can be done in this one? So we were given like a strip of 1 till 10 to the power 9, and each I is connected to an order. A person starts from shall execute the first 5 commands in the string, colors the last visited cell. If it was already black, it remains black. That is running on first page 12 only. So we have to like find what all uh, cells will be black at the end. That is our that is the demand of the question, and we have to print those cells in ascending order. In this one, brute force is not will not work because again it will be an of n square solution. So we're just trying to see how we can use it. Like, suppose if we had find out for till string I, then how we can use that thing to build the answer for I plus 1. This should be our idea. Yeah, your sixth problem is still running. And just think of what can be done. If our, our sixth problem got accepted, so our only problem that is left for today is problem D. Our of n square solution is not working. Now we have to just think of like how we can use the previous one. So let's reread the question again. Each cell is either black or white. Initially, and different cells are black. Now let's say, for anyone, for third example only, this was the one. Now suppose let's look for two people, this one and this one. So let's say let's rewrite the problem again. Initially, something like this is given. Initially, cells like 1 and 7 are colored. So initially, 1, 7 are colored. Now, suppose you want is now if you follow the first one, if you follow A, now this will get colored. Follow AB, this will get colored. If you follow A will move here, B will move here, and A will like this one. Now, if you follow fourth one, now let's look at what all it is visiting. A, B, A, B. So first, after following A, it will visit cell number 2. After moving B, it will let's number also these guys. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, and so on. So after first it will move to 2, then it will move to 4, then it will move to 5, then it will move to 6. This is what it will be moving and it will color 6. 6 will get colored. Now the next one is A B A B B A B A B B. If you look for this one, it will again start with 2, then move to 4, then will follow 5, then it will follow 8 and then 9. Okay. So if we look for both of them, these three operations are same only. The reason being is both are starting from one place, executing this much operation, whatever, then it is executing something. It will move to here. But till here, nothing is getting affected. So similarly, this will start, it will follow first three operation, reach here. Now it will have to follow other three operations. Similarly, if there was another string, like this, these four operations will be same because it is only affecting, getting it affected by the last number. So this should be our idea for solving this problem. Basically, if uh, let's say I has followed I steps, but our cells will be getting affected by the ith step only. Till I minus one step, nothing is getting affected. So I plus one will also follow same I minus steps, same thing only, and then it will follow the next two steps. So we have to use that idea in mind and then try to like solve this one. So let's say if we use that idea, then I think this should work out like because I minus one is same, then for each I only last two operations are different. That is the basic idea for this problem. Let's try to code it out and see if it is working or not. We have to let's say store all the maybe we store the preset only. There are total and roll are plus. You can even store let's say two and white cell also. There's white block. Mm, so right here if black dot contain black is not containing, then you can simply add in the white. And finally, if white dot size somehow is greater than equals to n plus 1, then we can break it out. Now we have find out few black and white cells. We can even we have to take screen as also input. So for I, only last two will same thing. Okay. If I equals to 0, yes. So if I equals to 0, the first one will only change it. So let's say here, if first one is white or it is black. No, I think it's black and white. Sorry, A and B. Sorry. If it is A, then we have to move to the next one. Next one. Means move from X to X plus 1. And if we then move to next white. Yes. So currently we are at 1. So in this one, we will move to 2. So black will have 2. And we can simply, if white contains 2, we can remove from white. We have to move to the next white. So if now for this thing, next white will be like simply white dot ceiling of 2. And yeah, simply we can remove it from this thing and remove black. Sorry, add in the black. Now for I equals to 1, uh, both last two will be affected, and we also have to store like um, what is the last visited, so that this will be useful when solving this one. So here, so this will be different to j plus plus. Now, here is here, and this last visited is one only, and radius is that's the last visited. Okay, we move to ideal question. As we look for the ceiling of this thing, now we just have to add in this one, black dot add ADX, and if white somehow contains this number, we can remove from the white. Now, only thing is, if j equals to 1, then in that case, last widget will be equals to our ADX. I think this will be valid for this case also, so we don't need else here. We can directly put else here only. And finally, we can print the black. So, okay, now start with the print out. Now, if we run on the game space, we have only 56 minutes. We set array, so this will be okay. We have to print black. So this is our output. Let's take it from here. First is 5. It should be 4 only. 2, 3, 5, 6. But we are getting 2, 3, 4, 5, 6. See why? That is this should be outside of this, not here. Now we will run it because in each operation only one cell should get affected at max. So 1 is 2, 3, 5, 6. Just whatever. Let's continue with that. We will increase some time in the contest. Use it to use it to let's see our for the sixth problem. Yeah. So for the first test case, we are getting 2, 3, 5, 6. Second is 1, 2, 3, 4, 6, 9, 10. Third is again 7, 1, 2, 3, 5, 6, 7, 9. Fourth is 3 and fifth is 5, 2, 4, 6, and yeah. Yeah, we are getting correct answer for the given test cases. Now let's check for all the hidden test cases if it is working or not. So D, submit our code. It might take a while. In the meantime, I will try to explain the approach for this one. So what I was doing is we figure out somehow that for when we are uh, like doing for I, its first minus 2, let's say, operation are same as what it was for I minus 1. So this was the basic idea for this one, and that only we did it here. We find where it reaches after I minus 1 approaches, and then just we add in the black that index, and finally we print those index. So this was the basic idea for this one, and yeah, our this problem got accepted. So overall, like we are able to solve all the six problems. We had some difficulties in the problem four, but others was like comparatively easier to this one. So my idea for like making these all live session is just to explain you like how my thought process goes on when I'm solving new problem. So this is the whole idea. If you like it, then yeah, you can even attempt these problems, which are its link is given in the description. And I will be back tomorrow. Maybe try similarly. I will try few more problems, selecting randomly, and we will see how it goes. Thank you.